Hi, fifth graders. Today we're going to be working on Home Connection, page 5 and 6, titled Better Boxes. Before we begin, please double check to make sure that your paper has your name and number up at the top. I'm going to zoom in a little bit so we can see. All right. Before we start, we are going to try to use this strategy to make sure that we are reading our word problems very carefully, because we have some word problems today. So whenever we see an action in the problem, it's asking us to do something, we're going to circle that word. Whenever we see a number and a label, we're going to put it in a box. And whenever we see the question, we're going to underline it. Okay? So keep that in mind as we're reading the very beginning. Brad found some additional boxes in his storeroom. He is wondering if these boxes will work for packaging some of his hand-stitched baseballs. For each of the problems, assume that a ball fits into a 1-by-1 space. Use numbers, labeled sketches, or words to find the answers. Show your work. So we have some numbers here. And I'm also going to put the word space in the box. That kind of goes along with our label. Any actions we see, we're going to circle. So we need to assume it's an action. We need to use numbers, labeled sketches, or words to do something. We also need to show our work. That's an action. All right, let's look at number 1. How many baseballs would fit in a box that has the dimensions of 3x5 times 2? I'm going to put this in our box. This is a number. The question is asking how many baseballs. So I'm going to underline that. So basically what I'm going to do is I'm going to take this number, this expression, this equation, and I'm going to solve. So we always start with what's in parentheses. 3 times 5 is 15. Now I take that 15 times this 2 and I get 30. Let's put a label on it. 30 what? 30 baseballs. I'm going to circle my answer and I'm going to make sure, did I show my work? Yes, I did. Right here is how I showed my work. I use numbers to do so. All right, number 2. How many baseballs, that's the question, would fit in a box that has the dimensions of 2 times 4 times 5? I'm going to put that in a box. So again, I'm solving 2 times 4, parentheses, times 5. Solve your parentheses first. 2 times 4 is 8. Then I take that 8 times this 5 and I get 40. 40 what? 40 baseballs. Go ahead and circle your answer. Again, we showed our work by using numbers. Number 3, how many baseballs would fit in a box that has dimensions of 4 times 3 times 6 in parentheses? How many baseballs is the question? I'm going to underline it. 4 times 3 times 6, and this is in parentheses. Always start with the part that's in parentheses first. 3 times 6 is 18. Take 4 times 18. 4 times 18, that's not one that I know right away off the top of my head. So I'm going to use a thinking strategy. I know whenever I solve something times 4, I can take it times 2 first. So I'm going to solve 18 times 2 first. That's the same as, here's what I'm thinking in my head, 18 plus 18. 18 plus 18 is 36. That's 18 times 2, but I need to take it times 4. So I'm going to double this. 36 plus 36. 6 plus 6 is 12. Put my 1 up here and my 2 down here. 3 plus 3 is 6, plus 1 more is 7. My answer is 72 baseballs. Circle my answer. And again, I showed my work with numbers. Number 4. How many baseballs? Let me see if I can adjust the screen here. I got a little blurry. There we go. I think it's a little less blurry now. How many baseballs would fit in this box? The question again is how many baseballs? Before I even start, I'm going to think about the different ways I could solve this. I could count up all the squares or all the cubes. That would take a little bit longer. It's maybe not the most efficient, and it's hard to see all of them. So before I solve, I'm actually going to label the dimensions of this prism. So right down here, how many across is it going? 2. How many on this side? 2. This makes up my base, and we know that our base is what we put in parentheses. 2 times 2. That's my bottom layer is my base. Now we're going to count this dimension right here to see how high it is or how many layers. 1, 2, 3, 4, 5, 6 layers high. That goes over here. So this is my equation. 2 times 2 in parentheses times 6. Now we need to answer the question of how many that is. 2 times 2 is 4. Take 4 times 6 and I get 24 baseballs. Circle my answer. Next, how many baseballs would fit in this box? Again, let's start with dimensions. Counting these up wouldn't be very efficient. So I'm going to find this dimension first. 1, 2, 3, 4, 5. This dimension next. 1, 2, 3, 4, 5. That makes up my base. 5 times 5 is my base. And then how many layers or how high? This dimension right here. 1, 2, 3, 4. This is my equation. I'm now going to solve. 5 times 5 is 25. Now I have to take 25 times 4. My thinking strategy whenever I take 25 times something is money. I think of quarters. Quarters are worth 25 cents a piece. So if I have 4 quarters, I have 100 cents or $1. I'm going to label it baseballs though because we aren't talking about money. That's just a great strategy for me to think of my 25s when I'm multiplying. All right, let's flip to the back side. How many baseballs would fit in this box? Not going to count them. It's not efficient. Let's label our dimensions instead. This dimension first. 1, 2, 3, 4, 5, 6, 7, 8. This dimension next. 2. That's my base. 8 times 2. Put it in parentheses. Then this dimension is last. This is how many layers? 1, 2, 3, 4, 5, 6 layers. Time to go ahead and solve. 8 times 2 is 16. 16 times 6 is what is left. 16 times 6 is what is left. That one I'm not really sure on. It's not one that's easy for me to think of. So what I'm going to do is I'm going to do this. I'm trying to solve 16 times 6, but I'm going to split the 16 up into 2 different numbers. A 10 and a 6 make up 16. So now I'm going to solve 10 times 6 first, because that's easy for me. 10 times 6 is 60. Next, I'm going to solve 6 times this 6. That's easy for me. 36. I take these two numbers and I add them together. 0 plus 6 is 6. 6 plus 3 is 9. I get 96 baseballs. Let's go on to number 7. Brad is hoping to package exactly 48 baseballs together. 48 is a number, and here is its label. I'm going to put it in a box. He's hoping to put 48 together. He sees the side of a box in his storeroom that is 2 by 3. What is he hoping the other dimension is? Here's the question. Here's another set of numbers. So we know that if part of the dimension is 2 by 3, we need to figure out what this dimension is that equals 48 altogether. So if I know 2 times 3 is 6, I need to think 6 times what equals 48? 6 times what is 48? 6 times 8 is 48. 8 is the other dimension. Number 8. Brad is hoping to package exactly 64 baseballs together. Put a box around 64 baseballs. He sees the side of a box in his storeroom that is 4 by 2. The box around that. What is he hoping the other dimension is? So same thing. I know that part of my equation looks like this, 4 times 2. We're trying to figure out what the other number is to get a total of 64. This is what we're trying to solve. This is going to be the other dimension. 4 times 2 is 8. 8 times what equals 64? The other dimension is 8. 8 times 8 is 64. You can go ahead and do the challenge if you'd like. Before you log off, the one thing I want you to do up in the top corner is I want you to write down your favorite season. Your favorite season. My favorite season is fall. I love the warm, sunny days. I love the cool evenings. I love the leaves changing. I love that it's football time. I love being outside this time of year. Go ahead and write down your favorite season. Of course, if you have any questions, please, please, please come and ask me before you turn in this assignment. Thanks, guys.